Okay, so welcome to CSIS27, which is the second programming class in Java that we have, which is also known as data structures, which is very, very important if you're going to be working in the field of computer science. All right, so let's look at the syllabus. Hopefully this thing opens up this time at least. There we go. All right. Okay, so whether you are in the online or regular class section, attendance is not required. You're welcome to come to class if you're in either section. If you need help, whatnot, or listen to the lectures, I'll be recording the lectures and posting the videos online. So your attendance is going to be measured through the class webpage. If you logged in, if you turned in the assignments, you're attending. Okay. Due dates, try to turn it in by the end of the week that it was assigned. Don't procrastinate, don't fall behind. That being said, if it's late, no big deal. I don't like taking points off if things are late. If you turn it in by the end of the semester, chances are I'll grade it for full credit. Okay, as long as it works. I offer a resubmit, so if something is not working, if it needs some work, I'll leave you a comment. You can read my feedback, fix your assignment, resubmit it, I'll regrade it. Okay? The book. I have all this other stuff in there. This is your textbook. Data structures and algorithms in Java. I really like this textbook. Alright, if you Google data structures, let's just do this. Data structures and algorithms in Java. Alright? You can find that book somewhere, right? And purchase it online. So that's what I would recommend. So that's the textbook. And let's have a look at it. Yeah, it's got pretty good ratings. It's a bit old, but guess what? These concepts haven't changed much. There's a few things that are missing in there, but you know, the meat, the essentials are great. And in my opinion, I mean, good luck finding a data structures with this kind of a data structures textbook with this kind of a rating. Okay, honestly, I love this book compared to all the other ones. Okay. The other ones tend to overcomplicate things a whole lot. This guy really narrows it down and, you know, helps you understand. Okay, so that's the textbook.
What version of Java is in that book?
I don't really know, to be honest with you, but it works with today's Java. Yeah, it will work. The only thing that doesn't work is the book has a whole bunch of applets. They'll tell you, okay, use this applet to do this, to visualize this and this and this. It's hard to get applets to work nowadays. Don't even bother. Don't worry about it. Okay, I'll help you navigate through it without it. And it's cheap. It's like around 30 bucks for the book. You don't have to pay like 120 bucks for it, you know. Anyway, so that's the book. And if you notice, there's another one in there from Carano, Data Structures and Abstractions with Java. There's another good book from Carano. I think I'm going to use a little bit of the PowerPoints from Carano. That's why I have it listed. Most of the rest is going to be from the top book, the Java Data Structures. Okay. So
Do you have the book listed as required book?
they're not required. No, I don't have them as required. Well, actually, the first one is required. You're going to really need it. Second one, no. Second one is optional.
I said you make the second one required, because that's the only way the books all ordered.
Make the other one required too.
Not that students have to get it,
Right.
but I think if I tell them to order both, they'll just order the required one.
It might be kind of hard for me to change it for this semester, but
Okay,
if you need some kind of a note,
Email, okay.
yeah, just let me know.
They'll take an email.
There you go.
Picked it up on Amazon pretty cheap, pretty quick.
No, but I think he's getting a
Yeah,
free.
the veterans is gonna pay for them.
Yeah. So, but if you need an email, I'll tell them it's required now.
Okay.
No problem. Okay. All right. So, yeah. So this is your class webpage. Everything that you will need for this class is going to be on this webpage. We're meeting on Tuesdays from 11:20 to 12:45. Semester goes from the 28th until December 16th. So the last day to turn anything for this class is December 16th, midnight. Okay. The drop without W deadline is the 10th of September. Drop with W deadline is November 17th. I hope you don't have to do that. Okay, the class content is broken down into 16 weeks. We're going to be going through a lot of the chapters, most of the chapters in the data structures textbooks. I'm just going to, one thing about the grades. If you are in student view, which is how you see this webpage, I have to warn you about the grades. Right? You have to uncheck this little text checkbox right here on top. Otherwise, Canvas is going to show you the wrong grade by default. Okay? Don't ask why, because Canvas people are stupid. Okay? That's why. But, I don't understand the reason why they wanted to have this in the first place. But let's say, for example, we have 17 or whatever, 20 plus assignments. You turned in 2 of them, you got 100% on both. This thing is going to show you that you have an A in the class. Unless you check this box off. All right? So make sure you turn this off because by default it will mislead you. Okay? Very important. In the summer, I had students who thought they were getting an A and then I ended up with a C, that kind of situation, because of the stupid gradebook. Okay, so make sure you uncheck this so it does not mislead you. Okay? All right, so I have it broken down into 16 weeks. Some of the things we're going to learn are, what's encapsulation, what is the difference between an abstract data type and data structure. We're going to learn about the different sorts. You might have learned about bubble sort in your previous programming classes. We're going to cover select and insert sort. We're going to learn about stacks and queues. We're going to learn about linked lists. I'm going to spend a couple weeks on the linked lists just to hammer it and make sure that you really get it because they're very frequently used. We're going to do more recursion and apply it into more advanced sorts. And we're going to examine even more advanced sorts like the quick sort, the shell sort. These are sorts where people got their PhDs for developing these algorithms. So don't worry if you can't come up with it yourself. As long as you understand how to do it, I'll be happy. I'm going to talk about trees, hash tables, heaps, graphs, and then we're going to finish up with when to use which one of these data structures. Okay? So I'm going to jump to week 1. And by the way, there's a welcome message in there that pretty much says what I just told you. If you need to contact me, send me an email. Include CSIS27 in the subject of your emails to me. I'll get back to you pretty quickly. In much less than 24 hours on normal days. Within 48 hours on weekends. Okay, usually should be within a couple of hours or faster. And if you're welcome to check with me before you turn in an assignment. When you turn in the assignment, you get a free regrade. I offer a regrade for you if you like. If something's missing points, make sure you check your grades frequently so that you're ensure that you're doing the right stuff. Okay, so week one is just really basic things. How to install Java on Windows. I have a video on that. How to set up path for Java on Windows. How to submit an assignment on Canvas. Okay. Anyone want me to go over this stuff again? No, Richard. You want me to show how to do the path thing? How to set up path on Java?
I've still got it installed.
You still have it installed? Okay, so I'm assuming that you know how to do this from the first Java class that you took. Okay? And I have some links in there. I go in much more detail in the Java class. I make my own video for that too. So if you don't, if none of you want it, just I'll leave it with these links here. All right, how to set up the Java. All right, so I'm just gonna go through this little PowerPoint here. And I have some review exercises for that as well. Okay, so this course covers abstract data types and data structures. So what's the difference between an abstract data type and data structure? An abstract data type is like a real world thing, like a line of people. How does a line of people work? Well, you have somebody at the front who's the last person to come in, right? Or the first person to come in, right? The last person comes in at the end, the first person leaves at the front. Right? That's the idea of a line of people, also known as a queue, right? And that's the abstract data type. What is the data structures? The data structures is the actual implementation of how we're going to do this in computer science. So the classes that we're going to write, the methods, and all that other good stuff, that is the actual data structure. So the data structure is the implementation. The abstract type is just, you know, the idea, how the general functionality of how it's going to work. That's the ADT. Data structures is the implementation. Okay. We have a couple of data types or data structures that we have seen already. Arrays, right? 2D arrays, vectors. Vectors are basically arrays that expand in size and shrink. Okay. Lists, linked lists is something we haven't done. Okay, so basically a linked list is kind of like an array of sorts, but the issue with arrays is if you're trying to insert an element or delete an element, right? So let's say, for example, just to give you an idea, all right? So let's say I have an array of something like 1, 2, 3, 4, right? If I want to delete this thing here, right, what I'm going to have to do is I'm going to have to shift this number to this place, and then I'm going to have to shift this number to this place, and then I have to tell the array to resize itself, right? So there's a lot of, so I have to go from this here, oops, all right, so first I'm going to have to move the 3 here, then I'm going to have to move the 4 here, and then I'm going to have to tell this thing to resize itself, right? That's so basically to delete this little number here, I have to shift this number over, I have to shift this number over, and then I have to resize the array, right? So if I am inserting in the beginning of an array that's like a million long, it's going to take me a long time to shift all these numbers, okay? And sorry, deleting. And the same thing, if I wanted to, let's say, this was the insert. I have to do 1, 2, 3 steps for inserting, for deleting the 2. Okay. And let's say later on I wanted to maybe insert. All right. And let's say I have an array that's something like this. Right. I'm trying to insert a 0 right here in the beginning. Okay. What I'm going to have to do is I'm going to have to do this kind of stuff. First, I'm going to have to basically tell this thing to resize itself. Right? So basically I'm going to have to do like let's leave it like that. So tell it to resize itself. Then I'm going to have to tell it get the 4, so move the 4 here. Right? Then I'm going to have to get and move the 3 here. Alright, so then I'm going to have to move the 3 here. Then I'm going to have to do the 2 here. Alright. So there's a lot of shifting to be done. Then I'm going to have to put them on here. And then finally I can, insert the 0 in the beginning. So you can see if I wanted to insert something in the beginning of an array, I got to shift everything to the right of it. I have to shift it one slot over, right? So I start with the last number. I shift this one over, then I shift the next one over, then I shift the next one over, then I shift the next one over. Okay, so there's a lot of shifting to be done. Instead of doing this, I can create a linked list. Okay, and I'll show you how to do that in this class. But the linked list eliminates all the shifting around. Okay, a linked list is basically you have one thing pointing to another thing, pointing to another thing, and if I wanted to insert something, I just have to basically, let's say I'm inserting something in here. I have to first basically point this thing to this one, and then I have to tell the other one preceding it, okay, point to this new thing. So there's only like 2 operations that are involved when you do a linked list. When you're inserting and deleting, it offers quick insertion and deletion. Okay, that's the advantage of a linked list. And this is just an example of a data structure. Okay, and then there's different applications for different purposes. Different data structures are more useful. Why would we want to use an array? Well, the array allows you to jump to a specific number. Let's say I'm trying to go to index number 1,000,001. You go directly to that thing if you want. Okay, you cannot go directly to the link of a linked list. You're gonna have to go and visit every one of them individually. So every data type has its drawbacks and it has its advantages. And in the beginning, I'm going to show you some of these basic things that we learned in array manipulations that we learned in the first Java class. That will be the topic in the beginning. Okay, so the phases, the different phases of software lifecycle, right? Identify and analyze the system requirements, design the system and the software units, implement the code and test the units, integrate the units and test the system, deploy, operate, and maintain the system. Okay, believe it or not, employers want you to know this stuff. Okay, so I've found plenty of internships to plenty of students, and one of the employers that was one of the things that one of the employers was asking in this spring. Make sure they know the 5 phases of the software lifecycle. That's the software lifecycle, and basically throughout as you're going through these different phases, you're gonna have to go back and readjust. Maybe the requirements are going to change a little bit. Maybe you're going to have to redesign the system a little bit. So there's a lot of back and forth. It's not just like, one goes after the other one. Okay. Problem analysis and specification. So most of these classes that we're doing here deal with pretty small programs. Okay. And the real world problems are a lot bigger. Okay, if you have to program a car that drives itself, it might take millions of lines of code. I don't know how many millions of lines of code are on Windows, but I know there's millions. Okay, so these programs that we're going to do, they're not going to be super long. Usually just a couple hundred lines of code. The real world problems, thousands of lines of code at least. Okay, so one of my experiences when I transferred to a fancy private school was from a community college. I was like the ace in community college. I was like the best. I killed it. I had such confidence when I went to the university, and then they gave me like, all right, this is a restaurant program, and we already have cooks, and we already have customers. We want you to program a waiter, multi-threaded. Here's 15,000 lines of code. Figure it out. That's a real world problem. Okay, so that's what's going to happen. Okay. Problem analysis and specifications. It's basically the contract between you and the customer. The customer comes in there and tells you, okay, I want a database program that's going to let me search this and this in this format. Okay, you got to write the program that matches their needs. And that's one of my gripes with this garbage code canvas, because I got certain requirements and they're not meeting them. Okay, even though they're getting paid to write the software, we have a checkbox in the gradebook that's misleading my customers or my students. Okay, I want that turned off. The job of a good programmer is get it done, fix this thing. Okay, they're just not doing it. So that's the precondition, the purpose, postcondition. Okay, precondition is conditions that must be true before something happens. Postconditions are things that are going to be true when the thing has happened. Okay. The different designs, top-down design, original problem is broken down into simpler sub-problems, right? You have the big problem of a car has to drive itself. You break it down. Different teams are going to work on different problems. One team is going to work on the rate, on the sonar or whatever the hell they're using, and to have a car drive itself. Okay, I know they have lasers and sonars and I don't know what else in there. Okay, so one person is going to work on this sensor, the other person is going to work on this sensor. We're going to put our work together into, the different pieces are going to be put together eventually into one big piece. The object-oriented design, if you've done Java, you know what objects are, the classes, okay? Basically the templates for things, right? Anything can be an object, you can be an object, the table can be an object, right? Objects have properties, those are their variables, and then objects have actions, or those are the methods or the functions. Okay, we can only change the properties through these actions normally. Okay. All right, and yeah, more details about. All right, algorithms are just step-by-step instructions to solve a problem. Okay, they don't have to follow an actual code. Right, you can use pseudocode, no real coding involved. And we're not going to use anything like go-tos. That makes our code unstructured. Go-tos are basically a thing of the past. That's how they used to do it in the good old days. And it made for programs that are very hard to debug. It created spaghetti code. That's what it is, right? So the spaghetti code is stuff goes up and down all over the place. Okay, it's much better to use loops instead of go-tos and ifs and elses, switches. Okay. Okay, texting, execution, debugging. Testing your programs is a big part of programming. You're gonna have to do a whole lot of testing in the real world. Debugging is always lots of fun when you have 15,000 lines of code and it's not working and you thought it was gonna work. Okay. Unit tests. Every team works on their own units, tests them, then puts the units together, starts testing the integration tests. Okay, and then when the whole thing is put together, does the whole system works as you expected it? Okay. In my opinion, Canvas right here hasn't been fully tested. We're their free beta testers for these guys. All right. And yeah, the V life cycle model is basically the whole thing is you go back and forward between the different stages of development. Sometimes when you're all the way at the final system, you have to go back. When you have finished the final system, you might have to go in the beginning and alter the specifications or the requirements. Okay, different kinds of errors. Whoops. Syntax errors, runtime errors, logic errors. Okay, syntax errors are errors that prevent the program from running. You forgot a semicolon, curly bracket, that kind of stuff. Runtime errors, the program runs, but maybe it crashes. Like, some exceptions. You forgot to have a fail-safe. The user enters a number, but they're supposed to enter a string or something. Program crashes. Logic errors are program runs, but it's not doing what it's supposed to do. So you didn't think it through the right way, maybe, or there's some kind of a bug in there. Okay. And what else? What else? And this is more of the same stuff. Life cycle of software. Okay, specifications, design, implementation, preconditions and postconditions. Okay. And I'll let you read through this. I have a little quiz that goes with this stuff.
Is that the first assignment?
Yeah, one of the first assignments is basically go through this PowerPoint and answer these basic questions. What's a precondition? What's a postcondition? That kind of stuff. Okay. So yeah, I'll leave that at there. You can read it. Let me look at the Java review here that I have. See what I have in there. Alright, it's a lot of pages. Okay, so some more things about Java. It's platform independent. The Java virtual machine can run on just about anything. Okay, it's object oriented. Everything's inside classes. Okay, you can inherit properties from one class. One class can inherit another class's properties by extending them, right? You can extend, you can implement. There's all kinds of different features in the language that allow you to reuse and recycle, things you have already developed. There's all kinds of packages that allow you to do things like you want to make a graphical user interface, no problem, very easily done with Java. Processing and execution, right? You write your Java program, that's the .java file. Then you compile that thing and you turn that into a bytecode, so that's the .class file. And then the Java virtual machine runs the class file, okay? Which is different from how things work in a compiled language. Okay, so Java is an interpreted language. You have an interpreter running the program. A compiled language, you have a final executable which just runs by itself. You don't need C++ to be installed for a C++ program to run. You need Java to be installed in order for a Java program to run. You need Python to be installed in order for a Python program to run. Okay, so that's the virtual machine. Compiling and executing a Java program. Man, I should have put this in the other class. So there's your picture. You have a Java source file. You have your compiler that turns it into byte code files. That's the .class file. And then the Java virtual machine reads this file, the class file, and executes it line by line to create the program. Okay? Objects. Objects, anything is an object. Table's an object, you're an object, dog's an object, car's an object, right? Objects have properties, right? It allows you to have one object, right? This is like the general class of tree, and from there you can create multiple objects or sub-objects. Maybe there's one tree here that's 2 meters long, there's another one that's 5 meters long, right? So you don't have to reinvent the wheel, you can just reuse things that are already created. Okay? And this comes in very handy when we do windows and buttons and those kinds of things. Okay?
I have a question.
Yes.
So why does Java programmer doesn't have a girlfriend?
I don't know that joke.
Huh?
What's the joke?
Because they treat everything as an object.
Ah, that's a good one. Why does the Java programmer does not have a girlfriend? Because they treat everything as an object. Okay. All right. You know why the programmer why was the programmer fired? Or no, why did the programmer quit his job? Because he didn't get a raise. And also, one more. What is the object-oriented way to becoming rich?
Becoming rich?
Yeah.
Have a class.
No. Inheritance.
What was that?
Huh?
What was that?
What is the object-oriented way to become rich? Inheritance. There you go. So I'm out of jokes. But we got one new one good one. By the way, do you know what's the computer science shirt? Like, do you know what it says on the back? You had me at Hello World. most people don't get the joke because they don't even know, they don't know either programming or they haven't seen the movie. You know which movie that is from? See, most people don't even know what I'm talking about. Jerry Maguire. Jerry Maguire, you Headman, hello. No? Google it. Anyway, all right. So, a Java program is made up of one or more classes. These classes contain methods, which we call functions in other languages. And these methods have statements, which are the single lines of instructions that tell the computer to do something. All right, attributes, these are the properties or the variables. Behaviors or operations, these are the methods. Again, just to be fancy, we code things with many different terms. Okay, a Java application always contains a method called main, not always, but if you can, the main is where the Java program is going to start. Okay, you can have many Java classes, but you cannot run those classes. The only place where you can, let's say you have class 1, class 2, class 3, they're all in the same folder. Okay, they don't have a main. If you try to do Java C file name.java, it will work. Java C works. But if you try to do Java file name, if the thing does not have a main, it will tell you, no, it can't run this, it doesn't have a main. So you can start the program from the class that has a main, and that class can call a whole bunch of other files. Okay, so I guess, yeah, Java application always contains a method called main so that you can, run the thing. Okay, but a class doesn't always contain a main. Here's your sample program. All right, looks like I wrote this thing. All right. Okay, representing data in Java, the different variables, the primitive variables like an int and a float. You have also perimeter or reference variables, I guess. So the reference are basically objects, like string is not really a basic primitive variable. It's an object in Java that deals with text. Okay. Variable is a name for a location in memory, right? This is your data type. This is your variable name, right? You should know these things from the first Java class. Okay, some of the primitive data types: byte, short, int, long, float, double, char, boolean, right? And the values of these and how many bits are used to store the information in memory, right? A byte is 8 bits, a short is 16, int is 32 bits, long is 64, float is 32, double is 64, and here you can see how big of numbers you can create using those. Okay, keep in mind the decimal numbers cannot be very accurately represented in binary. Okay, there's floating points discrepancies, which is why sometimes numbers get screwy and look weird and when we write programs. And I'll get into that later. Okay, the arithmetic expressions: addition, subtraction, multiplication, division, remainder, right? There's no power operator. You can't do the power of something in Java just like that. There's built-in power methods that you can use. Okay. There's no overloading operators like in C++. Like in C++, you can go and define the meaning of the plus. So if you want to have like a one object and you want to do plus another object, C++ wouldn't know how to do it. But in Java, that doesn't even exist. They said, why we're going to even complicate our life? Screw this. Okay, which I love. Okay. And another way that Java simplifies your life a whole lot compared to C++ is no pointers of any kind. Done. All right? We don't have to worry about pointers at all. Okay? And a lot of people are going, or in the past have asked me, well, how are you going to do data structures without pointers? Because it's all about pointers when we do this in C++. You can do it without pointers, so you're going to see it's actually easier. Okay? All right, division and remainder. So 14 divided by 3 is 4, right? 4 point something actually, right? 8 divided by 12 is 0. So what happens is, in Java, just like with C++, If you have one integer divided by another integer, it will assume that you want the result to be another integer, and it will cut off all the decimals, right? So you can have like 9.999, that's your result. It will cut off the 0.99 and it will leave it as 9. Okay, it's not going to round it up or down. It just deletes all the decimals. So if you have some kind of a formula where you have like, you know, let's say the formula of a sphere is something like 3 divided by 4 something something, it will always come out to be 0. Because the 3 divided by 4, I don't know if it was 3 divided by 4 or 4 divided by 3, whatever. The results are always going to be wrong because you have one little thing in there that gets converted into an integer every time. So be careful. The remainder operator means, you know, after you divide this thing, so if I divide 14 by 3, what is remaining? So in other words, how many times does 3 fit into 14? Tell me. 4, right? So 4 times 3 is 12. 14 minus 12, that's the remainder 2. Okay? Normally you wouldn't do this kind of stuff, right? So I'm not even going to go there. String concatenation means putting 2 strings together with a plus sign. Okay? So that's what it is. You have the string hello plus the string world. Now you concatenate them into hello world. Okay? The plus operator is also used for arithmetic addition. Keep in mind, it's not going to work for strings. So let's say you have the string 5 plus the string 5. The result is going to be 5, 5, right? It's not going to know how to do the math with strings. Okay? Data conversions. You can convert one data type to another by casting things, right? So if I have, you know, if I have double weight is equal to pi is equal to 3.14. I can go in there and I can cast this thing. I can say, all right, system out print pi equals, and I can do plus into pi. Alright, what that will do is it will cut off the decimal piece and show you the thing as an integer. It's not going to change the value of pi permanently, it will just show it for a little bit as something else. Okay, so you can do this data conversions. Alright, that's what the casting is. Reference variables, so we don't have so the reference variables are things like strings, right? So basically it's an object. Okay, it's not a simple variable, it's not a primitive variable, it's a variable of an object type. It's just something that we're going to get used to. Okay? Referencing and creating classes is done using the new operator, right? So I guess you should know that from the first Java class. I'm not going to get into it too much. Okay? Yeah, so we use the new operator to create new instances, right? You can use it for strings. This is an example of how you can make this equal to a new string. There's also a shortcut. You can just say title is equal to this, but both ways work. Okay? Creating an object is called instantiation. So I guess let me just jump to this. All right, so this is the lecture that I was giving to the Java class. All right, so this is a class for the first Java class. This is a class called human. It has one property called age, right? This here is me creating a new instance, right? I'm creating an instance called me, which is going to be a new human. Here I'm creating another instance called you, which is going to be another new human. Okay, this new human that I'm creating this way uses the default constructor, which is this, right? The default constructor is a method which has the same exact name as your class, right? So this is my default constructor. There's nothing in the parentheses. By default, Java will do this for you. All right, it won't initialize everything to 0 if you don't tell it specifically. Okay, if you want to have it as something else, you got to give it a different value. Okay, but if you don't, every number will be initialized to 0, every string will be initialized to null. Okay, so and then there's also an explicit constructor. The explicit constructor will take a new value and make the age equal to that new value. So right here, I'm sending the value 100 into that constructor. New age becomes equal to 100. Age is equal to 100. And I'm changing the value of age similarly to how I did it here. Okay? So these are the instances. Instance. And then another, this is explicit. This is the explicit constructor. Right? Explicit constructor. Okay, so what else? Yeah, that's the instantiation and instances. Alright, the ifs and elses and the loops. You should know that from the previous class. And move on. The ifs, there you go, more reviews of the ifs. If you have multiple things, if you have a single statement after an if, you don't need curly brackets. If you're going to have multiple statements after an if, you need a curly bracket, right? So I hope you remember that, right? So if I have if something and then I have statement 1, no curly brackets needed. But if I have if something and I'm going to have multiple things in it, statement 1, statement 2, right? Then I need curly brackets. Okay? Just like with the other programming languages. Okay? Or just like a lot of other programming languages. Okay, so the relational operators, right? Equals, not equals, less than, greater than, less than or equal, greater than or equal. And yeah, this is to check to see if something is equal, not to be confused with the assignment operator. You should know these from the first Java class. We have the not, we have the and, we have the or, which is similar to how we do it in C++. Okay? And some examples of ifs and elses in there. There's also a switch in Java. Some programming languages don't even have a switch. I'm not a big fan of switches. I just use ifs. I don't care. Okay? So here's an example of a switch in there. Loops, ways to repeat something. We have the while loop, we have the do while, we have the for loop, right? The do while is very handy if you know that something is going to happen at least one time. So if you have like a user entering information and you want to validate the input, do while is a good choice. A while would be something that, think of it as an if that repeats until something is no longer true. And the for loop will be when you know something, how many times something is going to happen. If I know that it's going to start at this number and it's going to go up to this number, I'm going to use a for loop. It's just shorter, neater code. Okay? And examples of a while loop, right? Similar to the if. If you have a single statement, you don't need curly brackets. If you're going to have multiple statements, like so, you're going to need curly brackets. Okay? And there's a do while, right? I'm surprised it doesn't have a semicolon at the end. Is there a do while? Yeah, there's a semicolon, right? So that's the syntax of a do while is you do the do, curly brackets, and then while, right? The difference between the do while and a while is if the condition isn't true, if the condition, which is this, is not true, the while is not going to happen. The do while is going to happen at least one time, even if the condition is false, right? And basically, yeah, just differences. The condition is evaluated at the end. The for statement, you have beginning, you have an and an increment or decrement, right? So start, stop, step. That's basically the format. Okay, same deal. If you have a single statement, no need for curly brackets. And there's an example with a for loop in there, right? There's only one thing inside this loop, which is this statement. so we don't need curly brackets. And how to choose the loop structure, I already mentioned that to you. Writing classes in Java, right? The object has a state, those are the variables and behaviors, those are the methods. The class is basically the template for an object, okay? And the unified modeling language diagram to show different classes, right? Or a class with different properties. Class with instances that have different properties. You can define your own classes. The name of the class, the convention is have it as uppercase. Names of classes are uppercase. Names of methods and variables are lowercase. Okay. Already told you about a constructor, right? They have a person class here with a bunch of properties, right? And this here is their constructor, public person. So notice in my example here, I didn't put public. Right? You can put public, no problem. Okay, it will actually work pretty much the same. The public and private are so that you limit the visibility of one class from another class. Okay? So I'll leave it as without any public at all. This. Anyone remember what this is?
That refers to the variables in that class.
This refers to the object itself, right? So for example, in here, let's say my constructor, I'm going to call this age here, age. So I'm going to end up having two different variables. So which one is equal to which one? Well, the class itself has a variable age, right? So if I say this age, it refers to this one. Yeah, this refers to this particular age. Okay? So that's what the this is. I'm going to undo this for now. Okay, so that's the meaning of this. In the first Java class, I think it's in chapter 3, there's an assignment where you had to swap values, and that's a really good one to master the this, you know. It's like 3.4, something like that, chapter 3. Okay, but this comes in quite often. You see it a lot in a lot of programs out there in the real world. Okay, so that's what this is. Okay. Okay. And arrays, right? Just basically kind of like a list of numbers. Okay. How you declare arrays, right? So this is how you would declare a float array, right? So a list of numbers of the float type, right? Grades, square brackets is equal to new float, and then the size of the array. Once you give the array a size, it stays fixed. You can't resize the array. If you want to, you can use vectors, right? But what we're going to do in this class is we're going to kind of trick the arrays into thinking that we're resizing them, that kind of stuff, so that you don't utilize the built-in vector. You're going to basically kind of create your own resizable array of sorts. Okay? You can check to see how many elements are in an array, right? If you have an array called grades, you can say grades.length, and that's going to show you how many numbers are in it. Okay? That's pretty much it as far as reviewing Java. Any questions? So nothing new. It's just the stuff that we learned in the CSIS24, pretty much. One thing is the toString. I'm not sure if I mentioned that. I'm pretty sure I mentioned it in CSIS24. Basically, if you have something like this, in here, if I go in there, and I do let's do it here, system out println me equals plus me. Right? If I do this, and I'm gonna do Java C human, Java human. All right, see what this is? Human is equal to this nonsense. Me is equal to this. Okay, so if I try to show an object or an instance of an object like so, it will show me the actual, some kind of a memory address of that object. Okay, if I want to override that thing, I do this business here. Public string to string. So I'm going to go in there and I'm going to override this thing. I'm going to throw one right here. Public string to string. Yep, just that. And then this thing is going to return, let's say this object has age equals plus age. So what I'm doing with this toString method is I'm overriding this default behavior so it does not show me this. Instead, it will show me this message. All right? So instead of showing me is equal to at 6D06D69C, what I'm going to see is it's going to show me is equal to, and then it's going to show me this message. This object has an age of this. Okay? So let's save it. Compile. Run. Alright? And now I changed it to this from this. Okay? So that's the purpose of toString. Yeah. Okay. So that's one thing. And let's have a look at what else I want to tell you. Okay. Lecture 1. I think that's from the book. Yeah, I went in there and I summarized these. Let me just download it. Alright, so this is just basically the summary of the stuff that is in the data structures book that we're using. Okay? What's a data structure? An arrangement of data in a computer's memory. So the implementation of an abstract data type. So the abstract data type is the real world, like a line of people. Data structure is how we're going to write a code for it. Okay? Algorithm, step-by-step instructions, how we're going to do this thing. Okay? And yeah, basically what's an ADT, right? And the types of ADT. We have bags, we have lists, stacks, queues, dictionaries, trees, graphs, right? Heaps. There's all kinds of different data structures. Okay? A bag is just an ordered collection of things, and you, in the review exercises, you're gonna have to make a bag. Okay, you don't have to do it for this week, but you might as well get started because you're gonna have to turn it in next week. I have it as an assignment next week. Okay. And then we'll get into the list and stacks and queues and all that good stuff. Okay, but in the very beginning, question?
Did we ever do a bag in the first thing? I've never heard of a bag, that's why I asked.
A bag? No, you haven't had to do a bag, but if you follow these review exercises,
Okay.
you'll see. Let's look at them real quick. So you see. Okay. So first of all, okay, part 1, just to warm up with Java, you can go to codingbat.com, write a couple of programs, do a few of the warm-up exercises. If you don't know what codingbat is, it's this, right? You can do a few of the warm-up exercises to warm up with Java, okay? Then step 1, the next step is, to get you comfortable with arrays, right? Write a Java program to accept a given number of item names and prices, then output them in reverse order, okay, in which they were input. In addition, output the average price if one of the items is named piece, otherwise output no average output. Okay, so I guess what you can do is you can create two different arrays. Alright, use a simple array string for the item names. Yeah, so I guess 3 and 4 kind of tie together. So what you're going to be doing is you're going to be creating, bless you, what you're going to be doing is you're going to be creating two arrays, right? This array is called names. It has 1, 2, 3, 4, 5 elements, and each of them stores some kind of a string, right? Grapes, cheese, peas, butter, whatever. And this other array, so this is an array of strings. This is an array of floats or doubles, right? Which is going to store the actual prices. All right, you know how to do that. Two different arrays. You can ask the user to enter information, put it into the first one, put it in put the names into the first one, put the cost into the second one. Okay, that's that. These are the parallel arrays. Okay, and add a static method to the program described above that outputs welcome to Gavilan before the items and prices are output, and then show that. So remember what a static method, how a static method is different from a regular method. Well, let me do this. So I'm going to go in there, I'm going to do new class, I don't know, example. Okay, so what I'm going to do is I'm going to do public static void main string args. Okay, and in here I'm going to have a void hello system out println hello. Okay, and let me save this thing as example.java, and go run this thing. Where is it saved? Desktop. Okay, so Java C example Java. Okay, so it's compiling, it works. All right, so let's say I want to try to call this method from here. If I just do hello like that, is that going to work? Should be, huh? Okay, let's try. So I'm just going to do Control B from Sublime, so it's faster to compile. Nope, doesn't like it. What is it saying? And by the way, it will give me the same error message if I did it here. All right. Non-static method, blah blah, right? So non-static method cannot be referenced from a static context. So this is a static method. This is not a static one. I can't call it like that. But if I do static void, then no problem. Okay? Java C example, Java example. There you go. So if you want to call a method directly like this, it has to be a static method. Okay? So that's what this is. Add a static method to a program described blah blah blah. Modify a program so the average price is calculated by a separate static method and returned to the invoker. The main method should invoke this method. Okay, so it's just basic practice with just making an array of like a couple of things, entering values into them, summing the things in the array. Any questions on this? Okay, so that should be a review from CSIS24, right? If you forget how to do the input, it's like chapter 4 or something. No worries. It's chapter 4, I think, in the CSIS24 is where we do the input. Okay? There was the scanner input, there's the buffered reader input, right? Scanner input was for entering numbers, buffered reader was good for strings and stuff like that. Okay, so that's that one. Now, what we're going to do is we're going to create like an array of things that are bundled up together. Okay, so what we're going to do is we're going to create a new class, a separate class called item, and that item is going to have its own two properties. One is going to be a string, just like here. One of the properties is going to be called, let's say, a name, and the other one is going to be called a cost. So now this class called item has two things in it. It has two variables, name and cost. Okay? So that class, the item class, is going to be used just to, bundle these two things together. That's all we're going to use it for. Okay? And then, yeah, so this first piece is basically create that one, create the item class, so that you can create, instances of that class like so. Okay. The final step is, this is the bag. Okay, so this is the example of the bag. So the bag is basically going to be an array of this class. So instead of having an array of integers, we're going to have an array of items. How is that better than before? Well, you don't have to have two separate arrays. You just have an array of the object itself, which bundles up a bunch of data. Okay? And that's a bag. Okay? An array of objects is a bag. Okay? What are some of the properties of the bag? Well, you need to know how many things are in the bag. You need to know, you need to be able to insert things in the bag. You need to be able to search through the bag. You need to be able to delete from the bag. There's no specific order in things in the bag. When you go to the grocery store, they're just kind of, it's all in different order in there. That's the bag. Okay, so there's no specific order, but you can insert, you can delete, you can search through the bag for things, see if something is in there. You can sum up, I guess, the total of the things that are in there. Okay, so those are some of the operations that you should be able to do with the bag. Okay. So that is your warm-up for this. Yes?
In the real world, what would a bag be used for? Like,
Just like a bag.
okay.
Yeah.
Did you see it?
A grocery, or something that's, like cart. Shopping cart.
Cart.
Shopping cart. Yeah. You don't necessarily sort things by price in there. It's just a bunch of things. You can delete from it. You can remove from it. Yeah. Shopping cart would be an example of that. Okay, so that is pretty much all for this week. So what do you have to do? Go in there and put a picture in your profile. Tell me a little bit about you. Do the quiz for week 1, which covers, what's an abstract data type, what are the steps of the software lifecycle, what's the difference between data structure and abstract data type. Okay, and please do the review exercises. Just start working on them. Okay, if you get stuck on them, you're welcome to look at next week. And I think I have the solution right here. The Java review answer. If you click on this thing, then you're going to see the code that I pretty much wrote to do this. Okay, but do this just to basically verify the thing. This is what I meant by, having a bunch of, an array of things. Okay, so we have an array of items. In this case, it's an array of names or something. Okay. Anyway, so that's all I have for you. I am going to post the video. There's not much notes for me to post, but I'll post the video for this and every other lecture throughout the semester for your viewing pleasure. That's all I have. Thanks for coming. Thanks for taking the class. Hope to see you next time. Yes, sir.
Just a question for Canvas versus iLearn. Where would the lectures be listed here?
It's broken down into weeks. It's broken down into weeks like this. You just go to week 1. Here's all the lectures in here. Read, watch the following. These are the lectures. right? This one is read chapter 1 of the 4 data structures, and then the rest is all the stuff I covered, right?
So in lectures you capture from, will be added.
Yes, yes, the capture is going to be right here on the bottom, right underneath this house medicine. Yep.
What do you use, Camtasia?
Yeah, I'm using Camtasia. Yep.
Is there any book that you recommend that would just?
The book that I would recommend is listed on the syllabus.
Okay.
Yeah, and it's let's see it real quick. It is this one right here. Data Structures and Algorithms in Java from Robert LaFleur. It's one of the highest rated out there.
See you next week.
See, Andy? Alrighty.